All right, so we're going to graph a quadratic function with the equation being in standard form. So we have f of x is equal to a times the quantity of x minus h squared plus k. So we know that when we look at our a, how we want to determine if the parabola, if it's going to open upward or downward. We want to find the vertex. Then we're going to look for the x-intercepts and y-intercepts, and then if need be, we will plot some additional points. Okay, so let's look at the steps here. Here's our example. We have here f of x is equal to the quantity of x plus 2 squared minus 9. So this is our question that we're going to graph. So now, first of all, we want to determine if this parabola opens upward or downward. Now, because there is no visible number in front of the quantity of x plus 2, it's an understood 1. So our a here would be 1. So this tells us that the parabola will open up. It opens upward. So you have a visual as to what this parabola should look like and in which direction it will open up. Then, so let's write this in, that's part A and parts here. Part B, we want to find the vertex. Well, we know how to find the vertex. Our H and K. Our vertex would be what here? Our H is -2. Our K is -9. Next, let's graph. We want to find some intercepts. Now, it says here, find any intercept by solving f of x is equal to 0. The function's real zeros are the x-intercepts. So what this means, we want to find the x-intercepts or intercept. We're going to set this equation equal to 0. Okay, so we have here x plus 2 squared minus 9, set it equal to 0. Okay, and solve for x. How do we go about solving for x? We're going to add 9 to both sides. We have the quantity of, well, we have x plus, the quantity of x plus 2 squared is equal to 9. To get rid of the exponent of 2, we're going to use the square root. Take the square root property, use that. Exponent of 2 cancels out. Square root cancels. So then we have x plus 2 is equal to plus or minus, because remember when we use the square root property, we have two solutions, plus or minus 3. Then let's subtract 2 to both sides, and we have x is equal to -2 plus or minus 3. So then our solutions, we have x equals to -2 plus 3, or x is equal to -2 minus 3. So those intercepts we have here, we have -2 plus 3, which gives us 1, and -2 minus 3, that gives us -5. So what you would have to do, go on the x-axis, find 1 and -5. Here is 1, 0. Here is -5, 0. And if we want to, we can plot the vertex, which is at negative 2, 9. That is our vertex. Now to find next the y-intercept. Okay, it says here, finding the y-intercept by computing f of 0, meaning we're going to take our equation and let x equal to 0. So f of 0 equals to the quantity of x plus 2 squared minus 9. We have 0 plus 2 squared minus 9. 2 squared minus 9, that gives us 4 minus 9, and this is negative 5. So look for negative 5 on the y-axis. Plot that point. Now, just for some review, even though it didn't ask it in this question, I just want you to become familiar with it. Um, what is the axis of symmetry? It's going to be, remember, it's going to be a vertical line that we draw. Is x is equal to negative 2. We look at our h. Going back to our vertex, look at our what we call h. All right, so example 2, it says 2a, it says use the vertex and the intercepts to sketch the graph of each quadratic function. Give the equation of the parabola's axis of symmetry that we found, okay? And then use the graph to determine the function's domain and range. So now that we have everything that we need, we can sketch. So connect, and we have our parabola. Okay, so if you want to try to make that bottom half more of a U-shaped graph, you can do so. Now, if there wasn't any x-intercepts or y-intercepts, what we would have to do is create a table of values and find some points to plot to create the parabola. Now, look at your graph. The question is asking us to find the domain and range. So our domain, as we look along the x-axis, is from negative infinity to positive infinity. Our range, as we look along the y-axis, where does the parabola start? It starts at negative 9 and it goes all the way to positive infinity. There we go. This is our graph. We used all of the information that's needed to make the graph.